Alright, this is day 11. Today we are going to practice sketching the graph of a function that we have here in factored form. To be able to do that, we need to keep a couple of things in mind. You should have memorized how a graph will behave at a particular zero, a particular root, depending on the multiplicity of that particular factor. In other words, when I say multiplicity, I mean if I just have a plain single factor of x minus 2, like normal, you might say, that's multiplicity 1. And the graph will pass straight through that particular x-intercept. So, you see we have x minus 2, and here it's positive 2 because that's like setting it equal to 0. I don't know what happened just then, but let me try again. It's like setting it equal to 0, and we're adding 2 to both sides, so we wind up getting x equals positive 2 is the 0 that goes with this factor. That's why it's positive 2. Anyway, if it's a single factor, it just goes straight through. On the other hand, if it's a double factor, then it's a bounce. All right, the graph hits and goes back the way it came. Now, if it is a triple factor, then we have what's called an inflection. Now, technically, an inflection works very much like two halves of a parabola, but moving in a different direction. So here we have this is going to be the x-intercept. Now you can see basically that we have sort of a parabola shape happening right here, all right, sort of like a parabola. So if I kept going like with my parabola, it would do like this, right? Okay, and it would make this parabola shape. But so we swing down, but instead of going back up, this parabola goes the other way. So it curves inward like a parabola, but then it curves the other way. So it's like taking half of the parabola, the half that would have been up here, and just flipping it upside down. And that's what an inflection really is. But, so a lot of kids think of it in terms of it sort of flattens out and then keeps on going through. That's called an inflection. Anyway, you have to have all those things in your mind. All right, also end behavior we have to talk about. So when you look at a problem like number 1, we have to put all of these things together. End behavior, degree, does it bounce? Is it an inflection? So here's what I mean about a degree and end behavior. This is a degree 5. The degree is 5. I know that because I have a third power and second power. That's 3 and 2. Okay, without the plus 5 part, this would be x to the third power. Without the minus 4, this would be x squared. X to the third power times x squared would equal x to the fifth power. So I know this is degree 5. That's important because I need to be picturing the end behavior to be able to draw this correctly. Now, because is odd, right? That's what really matters. This is degree 5, but that's odd degree. Odd degree functions have the same end behavior as a cubic function, which of course is odd. If it's positive, it'll be like this, sort of like a capital N. If it's negative, it'll be like this. Okay, like an upside down N. When I say positive and negative, I'm talking about the leading coefficient. So see here, the leading coefficient is negative. So that tells me that we're dealing with this version of end behavior, like an upside down N. So I will encourage you to do all of that stuff in your head, but just off to the side, make a little end behavior sketch. So this is a odd degree, it's negative, so it will have the end behavior like an upside down N. Okay, so that tells me I need to start from up high and then it come do whatever it is. Now the zeros, because we have a factor of x plus 5, we have a 0 at x equals negative 5. And here we're going to have a 0 at x equals 4. Now this one is going to be a bounce. Okay, so I'm going to have a bounce going on here. And this one is going to be that inflection that we talked about. Alright, so start from up high, and at negative 5 I need an inflection, and then at positive 4 I need a bounce. So let's see how we do. Okay, so well, first of all, here's my negative 5, and here's my positive 4. So I need to come in and do my inflection, which again is sort of like half of a parabola coming this way. And then I do my other half of my parabola going out the other way. So there's my inflection. Alright, my only other x-intercept is here, so I need to get around there in time to do a bounce when I get there though. So that means I need to curve back a little early so that when I get there I can do a bounce. So if I do a bounce, that means I'm going to wind up going back the way I came. Now double check your end behavior. Notice that it's supposed to rise on the left, fall on the right. It does that. I have my inflection and my bounce where they're supposed to be. So boom, that's a pretty good graph. Alright, there's nothing here, don't worry about exactly how low you go. This is just a sketch. Alright, so I'm going to do these faster and faster as I go along, as I feel like you should have the idea. So here, this is the 0 is x equals negative 4. And here we have x equals positive 3 would be the x-intercept here. Of course, this one is going to be a bounce. And this one is just going to be straight through. Alright, because that's a single. So I'm going to bounce and then go straight through. Oh yeah, end behavior. Degree. Well, for this one, the degree is 3. The degree is 3, alright, because that's 2 and 1. So that's degree 3. So, and it's positive. So degree 3 is, the end behavior is like a cubic. And this one's positive, so it'll be like a right side up end. So there's my end behavior sketch. So that tells me to start from low. Alright, so I'm going to start from low, and I'm going to bounce, and then I'm going to go through. So it'd be something like this. Okay, bounce, and then go through. Okay, so something like that would be a good graph for number 2. Alright, number 3. Alright, number 3. So we've got x equals negative 5, x equals negative 1, and x equals positive 4. Alright, so negative 5, negative 1, positive 4. This is a bounce. This is through. And this is another bounce. End behavior, degree. Alright, this is 2, 4, 5. The degree is 5. That's odd, like a cubic. It's positive. So this will have the end behavior of a positive cubic. Okay, so that tells me to start from down low. So starting from down low, I'm going to bounce through bounce. So here we go, from down low. Okay, I'm going to come up in time to bounce. I'm going to swerve, but I'm going to come back in time to go through. Then I need to swerve back around in time to bounce again. Okay, so there you go. Alright, degree 5, alright, falls on the left, rises on the right. So far, so good. Alright, number 4. Okay, so we'll have a 0 at x equals negative 1, and we'll have a 0 at x equals positive 4. Alright, and this is going to be a bounce and another bounce. Okay? So this is degree 4, all right, 2, 4. So that's even. So that tells me it's going to have the end behavior like a parabola. Because it's negative, it's going to have the end behavior of an upside down parabola. So the end behavior will be like this, both sides pointing down. So that tells me to start off from low, and then I need to bounce and bounce again. So that's going to be like this, starting off from down low, and I'm going to come around and bounce. Then I need to swerve around and come back in time to bounce again. Okay, so number 4 would look something like that. Okay, so up in this area right here, I feel like I need to go up a little bit more. We have zeros at x equals -5, x equals -1, and x equals 4. So there's -5, -1, and 4. Okay? This is just going to go straight through because it's a single. This is going to be a bounce because it's a double. And this is going to go straight through because it is a single. Okay? End behavior. The degree. The degree of this thing, that's 2, 3, 4. So the degree is 4. That's even. So it's going to be having the end behavior of a parabola. Because it's negative, again, this is going to have the end behavior of an upside down parabola. So that tells me to start from down low. So starting from down low, I need to go through, bounce, and go through again. So that would look something like this. So starting from down low, I need to go through this one. I need to come back around in time to bounce on this one. And then I need to come around and go through again. Okay, through, bounce, through. So there you go. Number 5 would look very much like that. Number 6. All right, we have a 0 at x equals -5, and we have a 0 at x equals 4. All right, so there's my -5, and there's my 4. This is going to be an inflection, all right, because it's a triple root. And this one will just go straight through because it's a single. End behavior, I need to talk about the degree. All right, the degree is 4. All right, I got 3 of these and 1 of these. That's 4. That's even like a parabola. So, because it's positive, there's no minus sign in front, I know the end behavior will be like a positive right side up parabola. Okay, that tells me I need to start from up high. So I'm going to start from up high, I'm going to do an inflection, and then go straight through. So, alright, my inflection. My inflection, again, is like part of a parabola. Okay, and then I do the other part of the parabola curving out the other way. And then I will curve around and just go through. Okay, so inflection and straight through. Notice the end behavior is what it needs to be. So there's number 6. Okay, number 7. We have zeros at x equals -5, x equals -1, and x equals +4. So here we have, there's our -5, our -1, and our +4. Okay, this will be an inflection because of the triple root, and the other two will just go straight through. Now, end behavior, I need the degree to help me out with that. Let's see, I have 3, 4, 5. So this is degree 5. That is odd, so I know the end behavior is going to be like an n. And since it's positive, the end behavior will be like a right side up n. Okay, end behavior looks like this. So that tells me, most importantly, I need to start from below. And then I'm going to do an inflection and a through and a through. So here comes the inflection, starting from below. So my inflection is like a half of a parabola, and then starts off to be the other half of a parabola. But I need to swerve back around and go through this. So I'm going to go ahead and just swerve now and just go straight on through that one. Then I need to swerve back around and just go through that one. Okay, so there you go. Check out the end behavior. Falls on the left, rises on the right, just like we said. Okay, inflection, through, through. There's number 7 for you. Number 8 only has 1 0. All right, it has an x-intercept at x equals -1. So right here is my only 0. And that 0 will be an inflection because it is a triple. Now, obviously, the degree is 3. All right, you can only factor we have, third power. So the degree is 3. That's odd, which means that it's a cubic. So it's going to have the n shape, either right side up or upside down. But because of the negative leading coefficient, that tells me that the end behavior will be like an upside down n, like this. So there's my end behavior. So that tells me to start from up high, like this. But when I get to this point, I need to just do my inflection. Okay, so that should be a pretty simple graph, but it's going to do something like this. All right, like my half of a parabola. And then it will do something like this. Okay, something more or less like that is what I should see for, wait, what happened to my problem number? My problem number disappeared at some point. I'm pretty sure this was number 8. All right, people won't know what problem I just did. But that's problem number 8. Okay, that is it for this side of the paper. All right, now flip ANOVA. We need to be able to work in the opposite direction. So if I give you a graph, you should be able to tell me an equation. All right, and you're allowed to leave it in factored form, but still. We zoom out a little bit. Okay, so looking at number 1 here. Okay, so I see we have zeros at -1, 2, and 5. So right there, okay, so I've got f of x equals. So I have factors at -1, so that's like x plus 1. I have another factor at 2, so that's x minus 2. Then I have a third factor at 5. So that's x minus 5. See how they're opposite signs? That's how you do. And I left a little space here in case I need a negative sign in front. Do I need to put a negative on this one? No. This is a right side up n. So that would be the positive version of this. So we'll just leave it positive. Okay, moving on to number 2 now. I see we have zeros here. So I have a 0, let's see, f of x equals. So we have a 0 at -2. So that gives me a factor of x plus 2. Okay, but that is a bounce. So that tells me that this factor is squared because there's a bounce happening. Then I see another 0 here at 1. That gives me a factor of x minus 1. All right, now this is the inflection that I've been trying to draw. All right, this parabola and then upside down parabola. So an inflection happens when you have multiplicity 3. So I got to cube that. And then the last one, I have a 0 at 3. Okay, so I will go x minus 3. And that one's just straight through, so I'll leave that plain. Now, the degree is 2. Let's see, 3 more is 5, and 1 more is 6. So this is actually degree 6. So, you know, well, I guess I can just tell. It's even degree because and both arms are facing up, like an upward facing parabola. Okay, so this is the positive version, so I'm just going to leave it the way it is. Okay, looking at number 3. I have a 0 at negative 3. Okay, so that's a factor of x plus 3. I have a 0 at 0. So that's like x plus 0, all right? So that's just x. And that was just straight through, so I'll leave it single. And this is just straight through, so I'll leave that single. All right, but then we have one more at 2. So that tells me that x minus 2 is a factor. But this one is a bounce, so it should be squared. Looking at the end behavior, both arms opening up, I know this is an even degree function. Specifically, it's 4, but even degree. When both arms are up, that's positive, so I'll just leave it like that. Okay, let's move on. So, looking at number 4. Let's see, I have a 0 here at negative 2. So that's x plus 2. It's a bounce, so that is squared. I see another 0 here at 0. So that's like x plus 0, which is just x. Now this is an inflection. I don't know if you can see it very well, but you know, it doesn't just go straight through. It curves in and it curves out. So that's an inflection, so that'll be third power. But then it comes back and has another one here. All right, at positive 1, so that's x minus 1. And we have even one more at positive 2, so that is x minus 2. So that is number 4 for you. Number 5. I have zeros here, here, and here. So what do we got? Negative 5, so that is x plus 5. That is straight through, so that's a single. Negative 2, so that's x plus 2. Straight through is another single. And then we have positive 1, so that's x minus 1. And it is straight through, so that is again a single. This is an upside down n. So that tells me that this is your negative n behavior. So I need to put the negative on there, all right, to make it like an upside down n. By the way, I didn't talk about it, but this one, on looking back at number 4 for a moment, this has the n behavior of your n again. All right, and it has the n behavior of a right side up n. So that's what tells me that this was positive n behavior. So that's why I didn't put a minus sign on it. Okay. Now number 6. Let's see, f of x equals. So the one at negative 4 gives us x plus 4. Straight through, so just leave it a single. This negative 1 gives us a 0 at x plus 1. That's a bounce, so let's square it. This one here at 2, that gives us x minus 2. And that's straight through, so we leave it. And then we have another one here at 3. So that'll be x minus 3. And again, that is straight through, so we just leave it. This is odd degree, you know, 1 down, 1 up. And so is it negative or positive, though? Well, this has the same end behavior as a right side up n. So because it's right side up, that tells us that the end behavior, the leading coefficient, is positive. Okay, so number 7. So looking at number 7, I've got my first 0 is here at negative 2. So that'll be x plus 2. And that's an inflection, so that'll be third power. All right, next I have a 0 here at 0. So that's like x plus 0 again, which is just x. Now that's a bounce, so that'll have to be x squared. Next one is here at 1, positive 1. So I put x minus 1. That's another bounce, so squared. And then there's a final one here at 2. So I will put x minus 2. Now this is clearly even in degree because of the way both arms are reaching the same direction. Because they're both pointing down, like an upside down parabola, it will have the end behavior, it will have the negative leading coefficient, just like an upside down parabola. So we got to put the negative on here for this time. Okay, last but not least, look at, oh, not last. All right, 2 more to go, sorry. Number 8. All right, when you do a parabola one like this, it's kind of a special case because the easiest thing to do is to do it in vertex form. Now remember, vertex form is sort of like this. All right, x minus h squared plus k. All right, this sort of shape of the equation, this is called vertex form. And in this form, you could see that the vertex would be h comma k. It's the opposite of this one, comma this one. All right, so let's do that. So it's all about the vertex. So since the vertex is here at 2 comma negative 4, all right, that's going to tell me a lot about this equation. So I could write a function like this. It's upward facing, so no, it's going to be positive. Now, as far as the parentheses, it's the opposite of this one, so it should be x minus 2 squared. And then this one sort of stays the same, so it should be minus 4. Okay, so this is your basic deal. And you know what? I would accept this for your answer. But if you want to be really precise, you're going to find out what this the a value, this number in front, is. If you want to be lazy, you can just go on to the next problem right now, because for just a sketch situation, like all the other problems, we didn't get real specific. So, but this is not too hard, so I'm just going to go ahead and show you. All right, so look, this is how you could find the a value, if you will, the number that goes in front. So far we have, it's like we have y equals x minus 2 squared minus 4. But we're looking for this a value, so I'll just go ahead and put an a there. We can find it by plugging in a point, any point that we know. I could plug in the vertex if I wanted to. No, that maybe wouldn't be so helpful. Okay, not the vertex, because that would make a 0, and that's kind of a problem. But, for example, how about this y-intercept? All right, see this point right here, nice little point, 0, 8. Let's use that. Let's plug that in and see what happens. So 0, 8. 8 is the y value, and that 0 is the x value. So it's like 0 minus 2 squared minus 4. So we know every value here except for a. Now this 0, I didn't really even have to write it because that's just a 0. Okay, so if I square this, so I've got 8 equals a, and this is going to become a positive 4, right? Because I squared it, then minus 4. So I would just add 4 on both sides here. Okay, it's going to need a little bit more space. So far that gives me 12, all right, 8 plus 4 equals, and see this a4, can I go ahead and just write 4a, you know, same thing. And then of course in that last little step here, I will divide both sides by 4. All right, so those will cancel out, and I will wind up with a equals 3. Okay, which tells me that this will be a 3, so that is the true equation of this parabola. All right, I would have accepted it though with or without the 3. All right, anyway, last one, number 9. For number 9, we have zeros here. Okay, so that's negative 2, so that means I have a factor of x plus 2. That's straight through, so I'll leave it plain. And then I have another one here at positive 1, so that's going to be x minus 1. That's straight through, so that's a single root again. And then I have another root here at 3, so that'll be x minus 3. But that's a bounce, so that'll be squared. Okay. With that in mind, I just need to decide if I need a minus sign in front. See how both arms are facing down? Very much like an upside down parabola. So this will have a negative leading coefficient like an upside down parabola. So put a negative on there and you got a deal. That is how that would be the answer for number 9. Alright, I hope this video was helpful, and I really hope that you're not just copying off of me. Never watch a video with a pencil in your hand. I will see you on the next video.